In this session, we are going to see the reflection and refraction phenomenon of light. Before we go in detail, let us see the basic definition of physics. Physics is one of the branches of science that deals with energy, matter, and their interaction. One should learn physics to understand the fundamentals of nature, which helps to improve quantitative and analytical skills in the fields of medicine and engineering. Most importantly, we can understand the reasons behind the things we see in our day-to-day lives. Physics explains the logic behind the things we do in our day-to-day life, which are often left unanswered. You can find answers to plenty of questions like what is the reason behind the twinkling of the stars, why we don't fall while we are walking on the floor, also why we tend to move forward when the bus stops suddenly, etc., using physics in our daily lives. In detail, we are going to see about the light phenomenon in our day-to-day life. Optics is a branch of physics that studies the behavior and properties of light, including its interactions with matter and the construction of instruments that use or detect it. It focuses mainly on the electromagnetic visible spectrum. Coming to the first basic definition and the first phenomenon of light, nothing but reflection. The definition is when light rays are incident on an opaque polished surface, these are returned back in the same medium, and this phenomenon of returning of the ray of light in the same medium is called reflection of light. You can see here from the light source, light is emitted onto the object and reflected beam from the object is seen by the vision point. This is how the image is formed in the vision point. Let us take one more example, the reflection of light on a plane mirror. Here, the blue line indicates the mirror. If an object is placed in front of the mirror, we can see inside the mirror an image is formed, and also treating the vertical line from the mirror as normal, the object making an angle of I, which is nothing but angle of incidence, and the reflected ray is seen at the vision point, that is, which is written here as I. Here near the vision point we can see the reflected ray, which is exactly normal from inside of the mirror. Thus the image of the object is formed in the mirror. The behavior of light when it is reflected is guided with the following laws of reflection. That is, the first one is the incident ray, the reflected ray, and the normal to the surface lie in the same plane. And the second point, the angle of incidence is equal to the angle of reflection. Yes, coming to the reflecting surfaces, all types of surfaces reflect light. It may be a smooth surface or it may be a rough surface. Now, reflection by a regular surface that is smooth surface, is referred to as regular reflection. A rough surface reflects a parallel beam of light incident upon it in all directions. The small bumps and irregularities on the rough surface cause each of the light ray to reflect in different directions. This kind of reflection is called irregular or diffused reflection. Yes, in the first diagram you can see here a plain smooth surface like a mirror where incident rays are reflected just in the same direction, making a particular reflection angle. But in the second diagram you can see here there is a curvy surface with a zigzag pattern, which is nothing but an irregular surface. With every edge of the surface, the light gets reflected in multiple directions, and you can see here the diffused reflection is happening. These are the two different reflections which we have. Coming to the applications of reflection of light in daily life, the first one we can see here, the routine thing which we use in our laboratories, that is ammeter or an voltmeter display, which use a mirror to avoid parallax error. The reading is taken from a position such that the image of the pointer is directly under the pointer. Second example, you can see here the rear view mirrors which are provided at both the ends of a car to see the things behind the car. The second important phenomenon of light is refraction. You can see here the first image, a spoon is appeared bent or broken. Also in the second diagram you can see a glass slab is kept over the alphabets, where you can see a level up and down in the alphabets is being observed. This is the effect of refraction of light. This happens because of the bending of the light ray when it changes the medium. You can see here XY is the boundary between rarer and denser medium. Thus, we can say when light rays traveling in a medium are incident on a transparent surface of another medium, they are bent as they travel in the second medium. This phenomenon is called as refraction of light. Similarly, this refraction of light phenomenon is under the laws of refraction of light. First law, the incident ray, the normal to the transparent surface at the point of incidence, and the refracted ray all lie in one and the same plane. And the second law of refraction explains us the ratio of sine of angle of incidence to the sine of angle of refraction to be constant, and it is the refractive index of the second medium with respect to the first medium. Let us see examples of refraction of light in our day-to-day life. You can see here the first example is twinkling of stars in a clear sky. Second example, pool of water appears to be less deep than what it actually is. Third example, rainbow formation in the sky and camera lenses and glasses. These are the day-to-day examples of refraction of light phenomena. Yes, similar to the before diagram, we have here bent objects in water. The pencil appears to be bent when it is kept in the water. The light rays from the end of the pencil are refracted at the air-water boundary and bent away from the normal. The image of the pencil under the water appears to be higher than its real image. Thus, pencil appears bent at the surface. Yes, the similar thing happens when the vision point is under the water. Suppose, imagine a fish or a diver can see objects above the water surface, but the objects on the shore would appear to be in the air at different positions as shown in the figure. Due to refraction of light, a fish sees the image of an object at a position that differs from its true position. Yes, next example. Swimming pool appears to be shallower than it really is. This is due to the light rays from the bottom of the pool being refracted away from the normal as they enter the air. When the light rays reach the eye, they appear to come from a level up than the original depth of the pool. Thus, the real depth of the pool cannot be measured from the surface. The next example is twinkling of stars. The twinkling of stars is due to atmospheric refraction of starlight. The starlight, on entering the Earth's atmosphere, undergoes refraction continuously before it reaches the Earth. The atmospheric refraction occurs in a medium of gradually changing refractive index. Since the stars are very distant, they approximate point-sized sources of light. As the path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of the starlight entering the eye flickers. The star sometimes appears brighter and at some other time fainter, which is the twinkling effect. From the atmosphere to the surface, the refractive index is increasing. That is, the medium is changing from a rarer to the denser medium. Thus, whenever the light ray enters rarer to the denser, at every point it starts bending because of the phenomenon of refraction. Thus, instead of a straight line path, the apparent star position is changed now to the ray path, which is having a little bend in nature. This is the effect behind the twinkling of the star. Now, the main reason behind why do stars twinkle and planets do not? Let us see the second half of the answer. The planets are much closer to the Earth and thus seen as extended sources. If we consider a planet as a collection of large number of point-sized sources of light, the total variation in the amount of light entering our eye from all the individual point-sized sources will average out to zero, thereby nullifying the twinkling effect. Thus, we cannot see the twinkling effect with respect to the planets. The next example of refraction phenomenon is the reason behind advanced sunrise and delayed sunset from the Earth's surface. Yes, imagining an observer on the Earth's surface watching at the sunrise and the sunset, it is not exact at the horizon because the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. The actual sunrise means the actual crossing of the horizon by the sun. Here in this diagram, it shows the actual and the apparent positions of the sun with respect to the horizon. The time difference between actual sunset and the apparent sunset is about 2 minutes. The apparent flattening of the sun's disk at sunrise and sunset is also due to the same phenomenon. Thus, reflection and refraction phenomenon are the basic important concepts of optics. Thank you for the session.